The video is on the Student Companion Book, pages 2 through 4. Example number 1, represent the solutions of a two-variable inequality on a coordinate plane. So what we're going to be doing is taking our equation that we've been working with for the last several weeks, even months, which is y equals mx plus b in slope-intercept form. And what we're going to be doing is we're going to be changing it to an inequality, meaning we're going to use less than, greater than, or even including the less than and equal to, greater than and equal to's. But the equation, the y value is still going to be in the front, the mx is still going to be in the middle, and the plus b value is still going to be at the back. And we're going to graph the equations and write the equations just as we did before. So with our equation, y is greater than x minus 3, we graph that y-intercept first. So we put a point at -3 on the graph. Our slope is second, and we know that that is really a 1x. It is a positive one, so positive means we're going to go up. So we go up 1 and then to the right 1, and we plot the second point. Up 1 and over 1 to plot the point. Up 1 and over 1 to plot the point. Up 1 and over 1 to plot the point. And again, you can follow that pattern going the opposite direction in order to make sure that your line goes all the way across. Once you had all of your plots pointed, you could connect all of your dots to make your straight line. So we've plotted the points. Now, the second piece that's different is that we're no longer using straight lines. Sometimes we will, sometimes we won't. If it is a greater than or a less than symbol, you're going to use a dotted line, as referenced here. So all of those points that we originally had on our graph, we would connect those points with the dotted line in between them. If it is a greater than and equal to or a less than or equal to, that's when you have a straight line, which is what we're used to doing. The last part of graphing an inequality is the shading. So we've graphed all of our points that we started out with. We went ahead and did our dotted line to show that it's just a greater than symbol. If it is greater than, we're going to shade above the line. If it's a less than symbol, we're going to shade below the line. So because our equation is y is greater than x minus 3, we shade everything above the line on the graph. For our triad example, we're using the equation y is less than or equal to x plus 1 on the coordinate plane. We start with our y-intercept, so we're going to graph positive 1 first. After that, we're going to do our slope. We know that that is really a 1x. Because it is a positive 1x, positive means we go up. So we're going to go up 1 and right 1 to graph our points, up 1 and right 1, up 1 and right 1, all the way across the graph until we reach the edge. And then we're going to start over. We put our point back at our starting point. This time we're going to go down 1 and over in order to connect our dots all the way across both sides of the graph, down 1 and over. Now we can look and see that this is an less than or equal to, meaning we need a straight line, not a dotted line. So we can go ahead and connect all of those points with a straight line because it has that equal symbol. And then our last step is to shade. It is a less than symbol. Less than means we want to shade below the line. So again, we would shade anything on the graph that is below the line that we drew. For example number 2, it's representing equations with only one variable. So in this case, the equation y is less than or equal to -1. We would graph the -1 first, so we would put that point on the coordinate plane. And then we don't have any other numbers. So because of that, we can't use a slope to go up or down, positive or negative. There's no other values to graph, so our line would stay straight across. Because it tells us that it is less than or equal to, it means we need a straight line, not dotted. So we have our straight line all the way across our point. And then because it is a less than or equal to, we want to shade below. So we shade in everything below the line on the graph. It is a similar process for an x equals equation. So in this case, our x value is a positive 1. So on the x-axis, we would graph positive 1. But there's no other values in the equation. So again, we can't go up or down because we don't have any other numbers to graph. We simply stay on the x equals 1 point. Because it is not an equal value, it's just a greater than value, we go ahead and use a dotted line, only going through that number positive 1. Because it is greater than, we want to shade above the line or the positive side. So we're shading the positive numbers. For our tried example, we have y is greater than 3. We graph that 3 value first, so graph positive 3 on that y-axis. We don't have any other numbers, so we know that this is just going to be a straight line going across because we can't go up or down. It doesn't have an equal to value, so we're going to use a dotted line going across. And then because it says y is greater, it means that we're going to shade above the line. For our second equation, x is negative 4. Again, we graph that negative 4 value first. This time we graph it on the x-axis because it's an x equation. This line does have the equal to value, so it's going to be a straight line or a connected line. So we would draw that line going straight up and down. And because it says x is greater than negative 4, greater means we're going to shade above the line. So we're going to shade all of our positive values, anything above the line. In some examples, you may have to write the equation when given the image of the graph. So you want to look and see, where does your line start? This line starts at positive 3 on the x-axis. So because of that, we know that it's going to be an x equation. Normally, our equation would be x equals 3, but we're going to change that to the inequality format. It is a dotted line, so that means we know that our equation does not include the equal sign value. It's going to be either less than or greater than. And then we can look and see that everything is shaded below the line. The negative numbers are what is shaded, so that means we're going to want the less than. So our equation would be x is less than 3. For example B, this graph starts at negative 1 and the y-axis. Our next point, we would go up 1 and over 1 to reach that next point, up 1 and over 1 to reach that next point. And I can follow that pattern all the way across, meaning my slope is a positive 1. So our general equation would be y equals a positive 1x with a negative 1 starting point. But because it's an inequality, we're going to change our equal sign. It is a straight line, not dotted, meaning it's going to be either less than and equal to or greater than and equal to. Because the line is shaded above the graph, we know that it is going to be greater. So when we rewrite the equation, we have, instead of y equals, we have y is greater than or equal to the 1x minus 1. For our tried examples in letter A, we can see that that is a straight horizontal line starting on the y-axis at positive 1. So we would write our equation as y equals 1. There's no other values because the line is not going up or down. It's just a straight across line, so there's no other numbers in our problem. Because we are dealing with an inequality, we want to change the equal sign to either a less than and equal to or a greater than and equal to, because it is a straight line. Because everything is shaded above the line on the graph, we know that we're going to use the greater than symbol. So our equation becomes y is greater than or equal to positive 1. For part B, we can see that our graph starts at the origin, and we know that the origin represents 0. To get to the next point that we can read clearly on the graph, we have to go up 2 and over 1. That pattern continues up 2 and over 1, meaning we have a slope of positive 2. And our equation would reflect that as y equals 2x. You could put the plus 0 for your starting point, but we know zeros are not as important, and so it does not have to be written. Because we're working with an inequality, we want to change that equation. So our equal sign is going to become either a less than or a greater than symbol because it is a dashed line. We can see that everything is shaded below the line, so that means we're going to want the less than symbol. And our equation would reflect y is less than 2x.